Our moderator is going to be
You're the
John
moderator.
Olko. Or not John, I mean the speaker is going to be John Olko. John has been with the New Jersey DEP for 26 years. He's the acting bureau chief for the UST enforcement program. He's a certified petrotite line tester, and John is also the task force chair of the Ashwamo UST task force. He was involved with the development of New Jersey's UST program initially. So, anyways, John?
Good afternoon. Oh, come on. All right, I realize I'm in a tough spot. All right. I'm all that stands between you and happy hour. And I've been, no pressure, and I've been told that the instructions, I have to get the instructions of, it's the left elevator or the right elevator, not the middle elevator. Okay, everyone got that, left and right, not middle. To get the reception on the top floor, push S, apparently. Whatever S stands for, I don't know. Just press the one above 18, is it? I guess. All right. So thank you for attending and coming to our workshop. We were very encouraged by the amount of people who signed up for this, so that's great. So I'm going to go through line testing in the next little bit. We really need 2 days to really for line testing to sink in, and that's in the classroom, and probably several more days out in the field for it to sink in. But my goal here was to give you, here's my goals, duh. All right. Is to provide us some general knowledge about line and leak detector testing. To give you just some general information, not to make you experts, and just overall things you can ask. I'm going to go over what our experience is with our own testing equipment, and I'll get into that in a little bit. And we're going to look at some data, some real data that was submitted to us. And I think once you see it, it's really meant to give you the tools to when you go back to your office, whether you're a regulator or you are an owner-operator or a consultant, you all see this kind of information come across your desk. My hope is you'll look at it a little differently the next time you see it and be able to ask 1 or 2 questions about it. And you'll see what I mean when we get there. What this presentation is not. It's not an endorsement of one manufacturer or method. Okay, let me just be clear about that. I'm going to talk mostly about petrotype because that's what we have and that's what we use and what we're certified on. But they all do the same basic thing. And that's where you get to the basics. That's where we sort of start you off with. But before we even get to that, how many have actually been out in the field with a contractor and seen line testing performed for real? Okay, so a fair amount of you. That's good. How many of you understood it? All right, a little bit less of you. Okay, that's okay. That's okay. You know, we're from the government. We're here to help. And I don't expect you to understand it. It is complicated stuff. But it starts with this basic principle of a periodic test of piping may be conducted only if it can detect a 0.1 gallon per hour leak rate at 1.5 times the operating pressure. And it's probably the only slide I might read, just FYI. Okay? I tend to ad-lib if you haven't seen me give a presentation before. Well, this one's going to top those other ones. You wait and see.
I got my clock.
You got a clock? All right. So some more basic principles. Operating pressure, right? That line says 1.5 times operating pressure. What's operating pressure? What the? Hey, what's going on over there?
Shear valve.
What are we talking about? We're talking about the submersible turbine pump's operating pressure. Now, if you look at this picture, look at it closely, there's two things you should observe. One is, what's the first thing you see in this picture? That's not supposed to be there.
No, it's there's an open horizon.
Who said that? What'd you say? A tire. Why is there a tire in the bottom of an STP sump? Why? All right. Now the second thing might be a little harder to see, but if you look really closely, there's oddball thing number 2. That's the duct tape on the flex line. Okay. Operating pressure. Most turbines are set up to operate at 25 to 40 psi, give or take. Okay, there's not an exact, number, but that's generally the average. So if you think about that, and this will make a little bit more sense further on when we look at some data and operating pressures. 1.5 times the operating pressure. So let's say it was at 30. We're all somewhat intelligent. We could figure out that means 45, but you tested it at 50. Well, okay, that's pretty good. Oh, I tested it at 35. That's not so good. So when you see results, something you should be looking at is, well, what was the operating pressure and what did they test at? It's pretty basic, but yet overlooked. And myself and the rest of our inspectors in New Jersey, before we went through Petrotite training and started doing it ourselves, it sort of lifted the veil of, there's a lot more to this than just a piece of paper that says this line passes. Common requirement, any method, is pressure and time. Okay? They all basically act on those same principles. It's how they get there are a little different. So some of our more popular methods, again, not favoring one or the other, you have the Estabrook, Technologies, TLD1, the Petrotite, and Accurite. Those, at least in New Jersey, are the ones we run into most. There's probably others that you guys may see out there, but these are pretty common technologies, pretty common testing. What I'm getting at is all these methods, and Don hinted on this earlier, must have a third-party evaluation. Okay? Where does that come from? Where do you go to find out this kind of stuff? You go to the NUI, the National Work Group on Leak Detection. And one of the many wonderful things they do, and we can say that there's a couple people in this room that are part of NUI Glide. We have Don, who was, and we have Heather, who's the chairperson. Heather Peters, Missouri, chairperson, NUI Glide. And Tim Smith's on NUI Glide from EPA. Would love to talk to you about the wonderful things NUI Glide does upstairs while you're having drinks. But one of the things is reviewing leak detection system evaluations to determine if it works right. Does this meet up with what they say it does? And so if you're an inspector or you're just interested or you're having trouble sleeping at night, okay, you can go to the NUI Glide website. And on the website is a lot of great information. That's the home page, and it has, if you look over on the left-hand side of the screen, all these vendors of all different kinds of leak detection equipment. And if you were to pick A through F, you'd sort of see a screen like this, and it just starts listing stuff. And of course, I went to this one. There's the Estabrook write-up. And it gives you a whole host of information, just like Don was pointing out for ATG units. Same thing for line stuff. It's all there for your reading pleasure. And we're not going to read through all that stuff, but you need to be aware of it. You need to be aware that that resource is there for you to use, to ask questions. A little bit about a turbine. This is, if you've never seen it before, or if you never opened up a sump cover, this is what's under the sump cover, the turbine. And there's a lot of different parts up top that you can see, and a lot of stuff going on down under the tank that you can't see. For example, you never really, or shouldn't really, see the motor and pump that's all the way down the bottom of the column, the shaft there. You have your pressure relief valves, your leak detector ports, your capacitor housing. What I want to sort of focus on, though, is the functional element, and that's that funny-looking thing right there. And I have more pictures. Functional element. It does several important things on a turbine sump. It acts as a check valve. It contains what we call the functional element adjustment screw, or the functional element screw, or the dang screw that's rusted shut and we can't get it to frickin' turn. Okay? It acts as pressure relief. It allows expansion relief, relieving the pump pressure. It acts as a vacuum source, such as it's doing, right in this picture there. It's acting as a vacuum for a manifold tank, and it's an air eliminator. So there's the picture of it there. Here's a close-up. And if you notice, there's that black cap there. Underneath that cap is where the dang adjustment screw is. Okay? And I'll explain why that's a problem in a little bit. It's one of the problems in isolating the line, and I'll explain that when we get looking at this petrotite a little bit more. There's a cutaway of it, and you can see the top of the screw. There's the cap, and down in here there's an O-ring that can shut it off, and that's how you can isolate the line without a ball valve. Because, as we all know and love, and here's a typical picture, if you look down the left, there's a ball valve. Okay? In order to do a line tightness test, you have to isolate the line. The primary way would be if you have a ball valve that actually is there and works. Okay? Makes sense. But if you think about it, and what we've come to realize is, how often do those ball valves get exercised, really? Once a year if they're doing an annual line tightness test. So sometimes they don't hold, or sometimes they're just plain not there. So you have to have another way of isolating that line, and the functional element screw is a primary way of doing it. So with that in mind, how did we get into this crazy business of line testing? Well, we had this little thing called Superstorm Sandy, which I can't call it Hurricane Sandy. It has to be Superstorm Sandy. And Superstorm Sandy, like what happened with Katrina, generated grant money from EPA to deal with cleaning up messes in our state. So what we were able to do with some of that grant money was we were able to purchase some petrotites and get the training and test facilities that, to the best of our knowledge, that we can figure out have not had any line tests done, maybe ever. So the idea was to go out to these impacted sites in what we're calling the Sandy Surge Zone and look at these sites and evaluate them to see if their lines are impacted or if they had any, leaks or what was going on. When I was looking at my Superstorm Sandy picture, I decided, well, I wanted to just take you very briefly and sidetrack you a little bit to keep you off balance of some pictures of what we saw back in our initial days after Sandy. You didn't think that was coming, did you? The picture of the Holland Tunnel. What's missing? 5,000 gazillion cars. All right? It'll probably never be seen again like that ever, unless, you know, the Holland Tunnel shuts down, which it never does. That's the boardwalk at Seaside, which was all over the news nationally. Myself and one of our coworkers were fortunate to get up on the boardwalk a couple days after, because the state trooper that was half asleep guarding his post didn't really care what we did, and he's just like, yeah, go up there, I don't care. So we got up there, and it was a pretty amazing sight. It's hard to tell, but the boardwalk itself was in waves, because the sand and the water had just pushed everything up from underneath of it. It was pretty wild. This was what's left of a marina that was nearby, and all the, I guess they didn't get their boats out in time, so Sandy decided to put these boats all over the neighborhood next door, which is pretty interesting. That is a pile of debris that was being removed from all the impacted houses. And the name of SWAMO is what? The Association of Solid Waste. We have that solid waste in our name, right? State and territory. So, not that I hope it never happens in any of your other states, but when your state is impacted by a storm like this, you're going to run into this problem. And here's another thing that happened. You ever all remember the Wizard of Oz when the house fell on the witch? Well, there's a dispenser. So back to what I was talking about. We were testing the lines at facilities that are in the sandy surge zone, and, you know, to the best of our knowledge, haven't had a line test. And that was one major part of it. Another part of it is we're able to use this equipment at those same sites, but we're also able to assist operators at government-owned facilities to troubleshoot their problems. Looking at test results of independent contractors, which we're going to spend a good part a little bit later in this presentation. Get some real-world knowledge of what's going on out there. Get some knowledge about developing a contractor certification program, which we have. We just are really now looking at it and beefing it up, and I'll talk to you more about that too. So when we go to use a Petrotite, and I have one here, and we're going to open it up, and hopefully the video camera trick works, and you could see it up close and personal. We had a lot of things to consider. We had to deal with safety issues. We had to deal with lockout, tagout issues. And then we'll get into it, is like where to connect the testing unit itself. So when it came to safety first, I either made a mistake or I did the right thing. I'm not sure which. But the first time out, when we had our training, I invited a health and safety officer from our OSHA office out with us. And boy, did he have a lot of questions. He had some good questions, but questions that needed to be considered nonetheless, because the primary thing when we're working with this equipment and we're out there testing is being safe. And it is sort of funny because if you've all looked in a dispenser cabinet, what's one thing you have to do? You got to bend down to look in it. And his question to us was, oh, do you bend down a lot? We're like, yeah, that's sort of part of the job. So then I knew I was in trouble, okay? So that meant we had to come up with a safety plan, okay? So now we've got this well-worded, long safety plan to cover, you know, specifically for our guys going out in the field and doing this work. It was an unforeseen twist in doing all this. So we came up with a plan. And then, of course, along with that plan came, and Don hit it on a little bit too, a standard operating procedures for non-permit confined space entry. because if you stick your arm into that sump, you are breaking the plane and you are now in a confined space. And where are most of those ball valves? They're down, usually a lot of times in the bottom, and you got to reach down and get them. So we had to be mindful of confined space. We went out and purchased these Draeger LEL meters so that we can monitor the air within the space. They have a pump unit that has a piece of hose that could go down to the bottom, and you can tell, okay, there's no issues with going in, sump's clean and we're good. Some other safety issues we had to deal with was lockout, tagout. And at first we thought, okay, you can go over to the panel because you have to shut the power off to the turbines and find their fuse panel and find the circuit and flip it off and at least put a sign on it and be reasonably comfortable that no one would go undo that while you're out doing work. But we realized that wasn't the way to go either, because of our OSHA requirements are this. A little sign, your circuit breaker lock, and a padlock. And with all those things on there, you're good to go. But we had to take the steps, and it slows you down when you're actually out there doing this. Traffic. That's always a problem when doing inspections, is traffic. This more than anything, because your back is turned and you're focusing on this equipment and reading gauges and turning dials, and you're not sure, what's going on behind you. We use our trucks. This is just a picture. We put up some cones, and we try to do the best we can to keep traffic off of us. But it's always something to keep in mind. Other safety issues, of course, gloves, eye protection, reflective vests. My staff gets sick of me telling them this, but it needs to be repeated and repeated and repeated. Tools. The other unforeseen thing was we realized that we needed a bunch of different tools to really do this job correctly. So we went out, and Don Taylor was very helpful in all this. He's like the leader. He's a pioneer in state government, I guess, doing some line tests. And he had a list, and we added to that list. This is part of the list. If you want to get involved in this kind of stuff and you want to know what you need, see me and Don. We'll be glad to share those lists with you. Costs. I know this is what's on everybody's mind. Roughly, for one unit, this is about what you're looking at. Okay. And we'll be glad to talk to you some more about it offline or whatever. But for the $7,000 or so for one setup, it's paid for itself in just the knowledge we've gained and what we've been able to do in relation to getting contractors more in line with what they should be doing. And it's revealed to us that for many years things aren't getting done quite how they should be, and you'll see why. So this is the Petrotite, but before we get to that, I will open it up and I'll do a little show and tell. We need to go to our work truck and get some safety equipment, so we'll be right back. Charles, that's your cue. I told you this is going to be good. So we're going to pretend that the big giant TV monitor on the floor there is our sump. Now, to get through this presentation, you're going to have to use your imagination. Help me out here, okay? There we go. That is a great question, and we do hear that one. And that's actually a really good question, and I'll get into that a little bit more in a minute when we get back to the slides. Now, okay. So, I'm not quite ready yet because I'm going to put on my reflective vest and make this authentic. Okay. Yes, I'm going to put on my gloves.
Ready for the exam?
Now, the reason I'm doing this is this works a lot better if we could go out in the field and we could do this live. You get even more out of it. But since we can't do that, I'm trying to make it as best an authentic experience for you. Okay? But I didn't wear my grease-covered orange DEP shirt that sort of smells like gasoline. So I'm going to put on my gloves.
Where's your hard hat?
No hard hat required. That's in the safety zone. So this is our Petrotite. Well, actually, this is Don's. I thank Don Taylor from Tennessee for lugging all this equipment out for me. You can see it's got a handle, a couple heavy-duty latches, and this thing, I don't know, weighs like 50 pounds or something. It's pretty rugged. It's built to take a beating, and they take beatings. All right, the video is a little sluggish. Yeah. So, all right. So,
what y'all doing over here? Is there water in that gas?
Man, did you not see the barriers?
I want to know if there's water in my gas. I got it in my car one day and it broke down. I was not happy.
Did you contact your insurance company?
No, what are you doing? Is it here? Because I just filled up my car.
No, man, we are testing. Maybe you should go buy some lottery tickets.
No.
Go buy some.
No, I want to know what y'all are doing.
We are doing line testing to ensure that the lines are not leaking so you don't get water in your fuel so you can get home to your kids.
Okay, I'll watch.
Can you cross from the other side of the barrier?
You're going to make me stand out there?
Yes, because you might fall in the hole.
I'm standing in the hole.
Well, the hole's over there.
The hole's over there.
Fine, I'll go.
Thank you. Thank you, Heather. I sprung it on her at the last minute, but that way it's sort of authentic. Now, how many times has that happened to you? Okay, that's the real world. And it probably would have happened to us had we been able to go to a field site, but because 140 people standing around a gas station, that would not attract attention. But you put on one of these vests, break out some equipment, and someone's going to come ask you, what do you do? So, Petrotite. And again, after the presentation, you're more than welcome to come up here and take a look at it and smell it in all its glory. Don did a great job cleaning this out, but these things, they get dirty, they smell like fuel. When you do this line testing work, you get dirty, you smell like fuel. It's just part of it. So you'll notice you have, there's a pressure gauge here, and I have pictures of this on the screen, so if this doesn't come through, you'll see it even closer. And you have a burette. You have a funnel. And you have a whole bunch of lines. We'll just focus on this one line right here. And what this is called, Petrotite is called pigtails. They're the connectors that you would use to connect to the lines. Now I have this. It's not on.
What, a regular mic?
No, where's the mic? There's my mic. This mic. Here we go. Let me turn this on. Testing. Okay. So this is the line that we connect to the shear valve. I have some shear valves over here. And I have pictures of them. The test plug would come out. And then you would attach the pigtail into the shear valve. Well, now, when you would take that plug out, because what? We're under operating pressure, right? So, you start taking that plug out, what's going to happen? There's going to be some fuel that's going to come out. It's not the end of the world. It's not going to cause you to call, emergency response or anything, but we go through quite a bit of absorbent pads, keeping it contained. Now you're all connected. Life is good. What you would do, and I'll have more slides, is you would pour your fuel into this burette. Okay, and I'm making this very simplified. And Ed Kabinski's back there chomping at the bit. He wants to chime in. Pour your fuel in, and then you would start pumping your fuel into the line. Okay. Now, what I observed when I opened this up is that this one main line here has a hole in it from being bent. So this isn't going to work exactly the way I wanted it to. But if I keep my finger on this hole...
Where's the duct tape when you need it?
Where's duct tape when we need it? It's not going to work. The hole's too far gone. Try it there. It's not going to work. Anyway, the idea would be, I have slides of this happening, your pressure would increase, you'd bring it up to 50, the volume of fuel in your burette would go down and be pumped into the line. Okay? Assuming everything works perfectly, you're at 50, and then you would turn a valve, this valve here, and you would bleed off all the air that's in that line. Because when you took this shear valve off, what did you do? You introduced air into the line that you now have to deal with. And I have more slides. So then you're ready to test. You'd repump your line back up, and you take a reading. You're at 50, and your burette would be at 50, for argument's sake. And then, so your line's under pressure. You would then deal with time. Wait your 15 minutes. Read your gauges. Did you lose pressure? Gain pressure? Stay the same. Your burette's not going to change because you didn't do anything. Let's say you lost 10 pounds of pressure. Not the end of the world, because lines stretch. Things change in that piping run. Pump it back up to 50. Now your burette went from 50, let's just say 40. That's your change. And when you see the data, it'll make more sense. The idea being, as time goes on, this moves towards zero. From the get-go, it may be zeroed out. And that's where some of the magic happens sometimes when you look at results. And we'll look at that next. And we're done with the camera. It's not over yet, people. How do I get rid of this thing? The X out?
Yep.
Charles?
Yeah, just exit out.
I'm at 55 now.
Got 55.
Oh, 55 left. Oh, crap. Oh, we're getting done by 5. Okay, so there's the Petrotype unit. I opened it up. It's sitting here again. You're more than welcome to come look at it and play around with it. And there's all the different parts that I described. So there's a glass burette, a little bit clearer picture, hopefully. It holds 0.1 0.0 of a gallon. So it's a tenth of a gallon. Okay. It can be read as small as 0.0005 gallons, and it's also marked in 5 mil graduation. So the burette is what really we're concerned with when we're looking at measuring where we started and where we end. It's just another picture of the pigtail, and hopefully you can see that. There's the quick connect and the pigtail connections, and there's the actual end of it that you would use to screw into the shear valve. So when we go out, part of our question is always like, where do we connect? How do we do this? And you're looking around at the dispensers, and you're trying to figure out how these sites are configured, because there's also one other constant, and I think this is universal. There's not two stations in this great land of ours that are constructed the same way. They're all different. So you got to do some research, not research, but poking around and figuring out how are these piping runs laid out, what kind of piping do you have, and how many length of feet of piping do you have. The honest issue with not just Petrotype but any line testing, it's not the actual test. When you're all set up and you're going, the test that's like nothing. It's all the prep work and figuring out what to do. The test is the easy part. That's like the time you can take a break. So you look for your dispenser. In this case, you need a chainsaw and some brush cutters to get to it. Obviously, this guy's been out of service for quite some time, but that did exist. And here's a close-up of the shear valve, just in case it didn't come across on the video camera thingy. And there's the test plug. Okay, that's the main part of this thing. And you see it has that fusible link, the trip mechanism, and the shear point where if this thing gets run into, it shears apart. To find this, you have to look under a dispenser. It's not going to jump out at you. You have to get down on the ground, open the lock, and look under a dispenser. And sometimes you're going to find a shear valve that looks like this. Okay? This guy decided that, he needed to improvise with that little block of wood to keep it open. Now, fortunately, we were with some contractors, and they had the parts, and we were able to make the repair to that right then and there in front of us. Test plugs. So you're looking for a test plug that's actually being used, okay? You don't want to go with a test plug that hopefully you can see in this one, the ends are rounded off. Chances are, if that thing's in there really stiff, you're just going to round it off, that plug's not going to come out. Or there's this plug. It's never been removed ever. Not the plug you want to use. The reason you want to be picky about what plug you're using is you don't want to over tighten the shear valve plug when you're putting it back in and crack the shear valve. And what do you see there? That valve's been sheared. Now, it had nothing to do with line testing, but just to show you, it does happen. What happened here is he had a little drive off. The hose pulled the dispenser rocked, cracking the shear valve. But what didn't happen you heard it anyway. What didn't happen was the little arm, it stayed connected. It sheared. The valve never popped. So you had, if they want to pass it around or they come up. You had a geyser of gasoline under the dispenser because the valve didn't pop. So they went and hit the e-stop. The guy crawled under there and flicked it manually. So you think things like that wouldn't happen, but they do. But it's the same concept when we're out there doing this work, is making sure we're not over-tightening that valve because we don't want to crack that valve. And a blank. Why? I don't know. Oh, so there's one properly connected. Okay? Looks great. The key to looking at them and anything, even if you're not ever doing a line test or anything, you're just doing your normal job, you're doing inspections, and you're looking under dispensers, and they're telling you, I'm doing an annual line tightness test. First thing you can do is look around at all their shear valves and see which one of them has pipe dope on it. It's going to be white or blue. It stands out from all the rest. And you could walk through and look at all their dispensers, look at their shear valves, and when you don't see one that has pipe dope on it, you can say, are you really doing line tightness testing here? Or how did you do it? Because there are other ways of isolating line tapping in. One of which is the silver bullet. I'll hold that up. So there's a silver bullet. I don't know why it came up with the name silver bullet. I guess it looks like a Coors can. I don't know. Anyway. There's the bottom of it with an O-ring that would, basically what happens is you would take the line leak detector off of the turbine and screw this in place of it. It has an O-ring at the bottom. There's the top of it where you would then connect your Petrotite or other. Okay, this isn't just, silver bullets are used by other methods. So if you say to them, how did you test this line? There's no pipe dope anywhere. And they say, oh, I use a silver bullet. Oh, well, okay, that makes sense to me now. But does your results say that anywhere? That's a question you can ask them when you go home. You don't even need to know anything more. How did you do it? So for Petrotite, there's two protocols, a 60-minute protocol and a 30-minute protocol, and they're not going to belabor over the minute details of this too much, but basically each testing method has a protocol of how long the test is and what they're supposed to do. Okay, and you can read those to your heart's content. But for Petrotite, we're looking at least 30 minutes, and that's for a certified test. When we're out there and we do a test ourselves, we're not, if we pump this thing up and see it's rock solid, we're more than likely, we're not going to sit on it for half an hour. We're going to sit on it for a little while, make sure nothing changes, and we're done. They're not using our results for compliance or anything like that. We don't want to keep them shut down any longer than normal, which gets back to the initial question of when can I pump my fuel again? So when can I pump my fuel again? When can I turn on the pump? Okay? For us, we try to do it, as quick as we can. For a certified contractor to come out and do the line test, whether he's testing, if he's even just got one line, he's got to sit on it at least 30 minutes. But his prep time, as I was trying to accurately describe to you as best I could, is going to take him a little longer. So if someone comes onto a site and says, I'm testing 3 lines and they were there for 45 minutes, I'm going to say, I don't think so, because it takes you more time than that to set up all your cones, all your barriers, all your safety equipment, and figure out what's going on that site before you even start the test. So if you're seeing results, or you are the customer, and you see these guys are on your site and gone, ask the question, how are you doing this so fast? And as a customer, you have that right. So back to the Petrotite. There's just another picture of it. There's the burette, and I got a better picture of the burette. So there's a burette. It's got, you fill it up with fuel through the good old plastic funnel, which, good job keeping yours not broken, Don. Those funnels don't tend to last. You fill it up, and you have, for argument's sake, I did this the other day, you've got, 0.020 in there, and you pump it up to 50. This is what I was trying to show you earlier. So you pump that up to 50, and your burette started at 20, so that meant now you pumped it down to 0.009, sorry. So you push that fuel from the burette into the line. Makes sense, right? And then I mentioned about air. So we got to deal with air removal or bleed back, okay? And that's a lot of words under there. But basically, you got to get the air out, fuel, when you're using the Petrotite, so that you get a valid result, okay? So what you're going to do is you do that bleed back by opening up that valve up. All that air you put into that line by taking the plug out now comes blown back at you, goes back into the burette. Now you got all your air out. Now you can really start doing a test. And if you're to look at real world results, what bleed back would look like would be something like that. Let me get that arrow out of the way. And you can see over here, on the right-hand side of the screen, over there, they calculated bleed back. Okay, they did there's a calculation that goes by the amount of foot of line, the 200, what the allowable bleed back per type of line you have. In other words, each type of line, if it's fiberglass, steel, flex, has a different allowance. In this case, they were telling us they have APT Polytech, the light blue color. And so in Petrotite's procedures, the calculation for that is it's 200 feet of line times 0.00120. Okay, great. Plus 2 being FC, flex connectors, because flex connectors stretch as well. So all this is really accounting for is the stretch in that line. You have 2 flex connectors, and remember that, flex connectors stretch, because there's another data example that I'll show you. Times, flex connectors get 0.006 each. You add that all up, plus a standard 0.05 gets you to 0.302 gallons would be the bleed back. So at the end of the test, they're going to release all the pressure off that line, and they're going to get a number based on what flows into the graduated cylinder. In this example, they were allowed 0.302. They got 0.118. So it passes that bleed back test, that resiliency test. Fantastic, okay? And it'll make sense in a bit when I show you some other results. I needed to show you something good before we go down the road of evil. Okay? So you start a test. Now you're ready to start because you got all that air out of the line. You pump it up to 50. You're at 20. Okay, nothing is changing there. Now you introduce time. Now you can sit down, get a bottle of water, get cooled off, and see what happens. All right, so you wait 15 minutes. I'll be back. 15 minutes. I told you. That's how I get to 5 o'clock. See, I had a plan. I just made that up. So you look at your, after 15 minutes, uh-oh, your pressure dropped. Call the cops. No. It's not the end of the world. Remember, especially with flex line, or even if you have a whole bunch, you have fiberglass really doesn't stretch, steel doesn't stretch, but your flex lines will stretch some. So if you've got, 2 flex lines, 2 flex hoses on the lines, you're going to get some stretch. Your pressure's going to decrease. Your burette reading didn't change because you haven't done anything. All right, everyone sort of getting that? So you want to bring it back to 50 to get your second reading started. So that meant you're now down to 9. And it sort of looked like this. Your starting volume was 0.020, your ending was 009, so you had to change a 0.011. The idea being, now that you've got that stretch out of that line, you've got that figured out, the next time you pump it back up, it's not going to change at all. You want to get that trend to 0. 0 change in pressure, but more importantly, 0 change in your burette. So now we're going to have some fun. As if you weren't having fun already. Because I know you were. You're just hiding it. Results. Results are not a multiple choice test. Okay? When you get results, they should be clear. You shouldn't get some willy-nilly stuff. I'm going to let you guys read a slide, the next slide, and then we'll talk about it. I'll give you 20 seconds or so. I'm going to take a time out because now I'm That's good, good. Okay, so how many, you've gotten this sent to you, or you've either seen it at a facility, sent to your office, that's the only thing you got? Pass. Yeah, there's one. You could raise your hand, we're probably all guilty at some point, and you're saying, okay, that looks pretty good. That's what you should say. What? Wait, what? What is this? So we're going to look at some of this stuff. Again, this one, you look at it and you see, this microphone's giving me 3Ds here. Okay. He started his test, his pressure was 90, then he went to 60. He brought it back to 50. It went up to 60. Brought it back to 50. It went up to 60 because he's gaining pressure. And his before and after volumes each time changed. He lost 0.002. And I'm not sure if he's testing with the silver bullet. I'm not sure if he's testing. He closed the functional element screw. And his passing rate is 0.004. So those are some things, but there's one other thing here that, can anyone see another weird business going on here? He's got testing the regular line and the super line. There's something that stands out. What's that? Time. The times are almost the same. And that's interesting. Remember what the protocol is. It's 0.005 for 30 minutes. So I don't know where 0.004 came from. He's just being more stringent. I have no idea. How would he test them at the same time? He used a manifold. Okay? And that's fine. There's another picture. And we have one up here. Manifold is just, it makes it that you can test more than one line at a time, makes it faster and easier. Not the end of the world for some. So we look at this. Now, we're not looking at petrotite data here. This is an Estabrook report. What's bizarre here? He's got 3 lines, 2 passing, 1 he doesn't really say. And all those lines were rock solid right from the start. Now, petrotite is, I think, the only one where they're using fuel or a liquid to gain the pressure. All the other methods use a gas to build the pressure and maintain it. So these could be legitimate, but I really want to ask, really? And his applied pressure was 55, but we have no idea what the operating pressure is, do we? Let's go on. Now, you're really going to have to pay attention to this because the data is really, really tricky here, okay? I'm serious, people. Pay attention. Get ready. First thing to focus on, regular 1, okay, up top. It says regular 1. He applied pressure at 50, and he passed it, okay? There's his start and end times there. Start at 10, ended at 11:15. And his calculations, and he's saying it passes. Okay, he meets Estabrook's requirements. These, we flip now to Estabrook. All right, so that's regular 1. This is the super line. Okay, what do you see? The same start times, right? Diesel line. Caroline. And we go back. Regular. Super. Diesel. Caro. What's that? All the numbers are the same, Omar. That is correct. How? We were sort of flummoxed by this individual, and we looked at these over and over, and we're like, this is very interesting. So that's what we thought. How did he do this? So we obviously made some phone calls to this individual, and he said, I use a manifold. I'm like, well, how's the data all the same? Are you questioning me? I'm like, look at the information. Any person should be asking, why is this all the same? It turned out he allegedly he had a data glitch. So when he was entering his data into the system, it defaulted everything to that first set of data. So that's what he told me. I said, okay, well, mistakes happen, data glitch. You have your field notes where you can, redo them. Oh, I got rid of those. Okay, so you got to meet us back out, and you got to do this test all over again in front of us because we're not believing any of this. And this is where it gets even worse, because then we find out that he does not have a 3-way manifold. He had, what did he have, Greg? A 5 or 6-way? It was ridiculous. He had this octopus of a manifold. Well, if you check with Brad Estabrook says, 1 tester, 1 line, no manifold. So if you're seeing Estabrook results that are manifolded, let Brad know. And he will back you up 100%. To say he does not accept that. Okay? It's between you and Brad. But that's the way we play it out with anyone in New Jersey who is an Estabrook. So there was a bit of a phone conversation between us and Brad and his contractor, and that problem has now been resolved. Here's a good result. Again, we got the good and the bad and the ugly. This is what I showed you before, but now I'm including the results of their line test below, okay? And everything's good here. It goes to 0. It balances out. There's no change in volume before, after, and at burette. And then you went on to the next page, and you could readily find out what their operating pressure is. There in the middle of the page, it's 23. So you get a lot more information here. Or you could be handed something like this. This is a summary sheet that says pass, 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 pass. Oh, that's great. But what did it really tell you? Nothing. It told you nothing. This is what an accurate result would look like. I just threw it in there for, so you can see it. And this is the bottom part, but at least they're putting in their operating pressures and things like that. And the winner is this guy. So this guy submitted these results after going back and getting retrained on Petrotype, because we had enough of his silliness. 200 feet of fiberglass, no flex connectors. Where does that exist? Okay. Now, these results, they're submitted to us. It didn't take us long to figure out that this wasn't making any sense. His calculated bleedback, he came up with .050. I'm not sure of his math skills. His max, he says, is that what's circled there? His real bleedback in the field was .053. So he went over it. But he's just saying the line passed the test down there on the bottom. The line passed the test. Again, look at his volume readings. This is, I'll help you along here. His volume in the burette is .044. Here's the next line. It started about the same time. It's now .051, and then it changes to .029. If his pressures didn't change at all in any of those lines, how did his volume change? He was just writing down numbers. He just didn't have a clue what he's doing. He's just filling out the form, making it look like he did something. He's now suspended with a 6-figure penalty. So, summary, sort of, what did we find? Ball valves not functioning properly, functional elements that either failed or had bad adjustment screws. We found leaky filters. We had lines that have air pockets, broken shear valves. We constantly see, more than anything else, bad reports and data, and testers and contractors that really need to be retrained. And that's where that third-party training comes in, where it's the manufacturer of this equipment, that it's their name on it. So if you ever have an issue, the manufacturers of this equipment are more than happy to talk to you and to evaluate data. They protect this stuff like it's, their kids. It's their livelihood, it's their name on it. So they will always welcome a call from anyone saying, hey, I had this test done with your equipment. Can you look at it for me and tell me what you think? And they'll be glad to. They're glad to talk to you about it. Just make sure you have enough time to talk to them, because you might be on the phone for a while. But they're very well informed. We're going to skip that. I'm going to blow through how much time I have. 25 minutes? Oh, okay. So line leak detectors. We can use this to test line leak detectors as well. The one in the middle, that's what happens when you really, really crank down on one. It could actually snap, and that one did. We didn't do it. We didn't do it. We just observed. Just real quick, if you have a line leak detector, almost got a couple of them in his hands. Incidentally, I need all that equipment back, otherwise I'll owe the state of Tennessee some money. This is what they look like on the inside. When it's tripped, the position, test position, full flow, how a line leak detector is supposed to function if you've never known it, other than looking at a test result that says pass. What is it, what is it telling you? What does it tell you when it passed? It's supposed to trip when? When is a line leak detector supposed to trip? This is pop quiz. What's that? At 10 psi. So it's supposed to detect a leak, a 3-gallon-hour leak at 10 psi. What's that? So, and I encourage you to go, look at these slides at your leisure. And, you could look this up. I think if you Google Veeder or the Red Jacket LLDs, they have tons of information out there on their websites that you can look at and read this stuff. And I think it's really good to know, because it's one thing to open up with some, oh, yeah, they have a leak detector. Oh, and here's this little report that says it passed. Oh, okay. We should know how this stuff works. So here it is in a trip position. Pressure drops too low, the spring closes, and what happens at the dispenser? It goes and you're getting ticked off because all you want to do is get some coffee, get your kids to school, and stupid dispenser's not working, right? Well, it's because that leak detector tripped. And why did it trip? It could be tripped because it's bad. Could it trip because there's a, what's that? Bad solenoid, temperature change, or a line leak. In the test position, now you're getting somewhere. Piping pressure increases, diaphragm moves up, flows restricted to 3 gallons an hour, and it's hoping that you're going to get more pressure build up until it goes to full flow and you're flowing. Now, all this should have happened in a matter of 2 to 4 seconds when it comes to life. Okay? So when they're testing and you see on reports opening times and it says a half an hour, not that anyone would write that on there, who cares? It needs to do its job. It needs to be detecting a 3-gallon-hour leak at 10 psi. And again, we don't have the time or the time to go out in the field to show you how this works, but it does work to trip them. That's cutaways of what they look like on the inside. Okay? Electronics basically working the same way, except they get tested when the pump is turned off. And of course, if we had one, it'd be hooked into Don's unit there, and you can pick up, see the information on electronic line leak detectors right from the console and see if they're doing a 3-gallon-hour leak, a 0.2, and or a 0.1. That 0.1 being non-volumetric, and we don't accept that as a line test. A couple things you need to know about when tanks are tied together. Especially with mechanicals, this seems to be a lot more common. You've got tanks tied together. You got leak detectors installed in both pumps. Okay, that's not a crime. But those pumps, it has to be able to alternate which one's coming on, which one's going off. Otherwise, if they're tied together and coming on, now they're looking for a 6-gallon-hour leak. That's not what you're looking for. So if you run into that in the field, ask them, normally we call it an AB switch. Are those tanks alternating? Electronics, one leak detector on one is going to do them all, and they're doing it on the hang-up. But just be mindful when you see setups like that in the field. Contractor certification. In New Jersey, we have a rule that the owner-operator shall ensure that all services performed on a tank system are performed by a certified individual and firm. Okay, it's in our rule. Or under immediate on-site supervision of an individual certified in the correct category. Okay? So what does that mean? The certified contractor has to be certified in one of these categories: installation, closure, tank testing, corrosion protection. They could be one, they could be all. When we step onto a site and they're doing a tank install, for example, and you've got 15 guys out there, we'll ask the question, we know this is the Acme Tank Install Company. Where is Joe Smith, who's the only person who's your certified installer? Oh, he's in Florida. Oh, crap. That's not good, because the rule requires he has to be on site. And when that happens, we tell them, you have to stop working now and shut them down. That's an exaggeration, but not too far from the truth. Same thing with line testing, tank testing, CP testing, and closure. They have to have certification, New Jersey certification, in addition to having that third-party certification from Petrotype, for example. So if someone comes on a site and says, "Oh, I'm a certified, I'm good for tank testing." Okay, that sounds good, but where's your Petrotype certification? Oh, snap, I forgot about that, or I forgot to renew it. And the easy way to check, not just Petrotype, Esterbrook, any of them, is you could call them up. Even if your state doesn't have a contractor certification program, they still need to be third party on this or other equipment. Okay? So you can call them up and say, "Hey, I got this guy out here. He's using the Petrotype. His name's Joe Schmo from Idaho. And is he certified?" And you'll hear some people's, they usually get back to you pretty darn quick because they're excited. They go, "Oh, I got something to do now." The regulator called me and, hot dang, I want to find out. And they look it up and they'll tell you, "Yeah, he's certified." Or, "No, never heard of him before." Or, "Yeah, he expired 2 years ago." What do you got then? A bunch of bad results. Okay? So keep that in mind, whether or not you have a cert program or not. One of the things that it allows us to do is deny, suspend, or revoke, or refuse to renew the certification, and we can issue penalties for violations, and we've done that in several, and we are currently working on a list that previously hung up in my office before I moved, and I had to erase the list, and now I got to put the list back up. But we are finding, issues. It's data issues, and it's issues where they've laxed on their certification on the equipment that they're supposed to know how to use. So, yeah, it's important as a regulator. It's important to know as the customer that's paying these individuals to do this work. The contractors want to know, are there, the guys they have out in the field that they're employing, are they doing this the right way? They want to know. So if you ever have a question about, I don't know, if this guy's really doing what he's supposed to, feel free to call your contractor. They want this stuff done right. Now, if the contractor is all on the same person, then you got another issue, because you run into that where you got the contractor is the company, and those are the guys that seem to run into more of a problem with us. And with that, there's my contact information, and I am done. And I am how much early? 14 minutes early, so we have time for questions, or if you want to throw stuff at me, whichever. Yes. Questions. And then we might try to get Don to do some Vita root printout stuff.
Do you have many problems with contractors leaving fittings on the crash valves so that they can come back, snap taps?
Yes, snap taps. There was a picture in there with the snap tap, and we tell them you got to get those off. Yeah, the snap tap, if I can get back to it fast enough.
We have been doing the same.
There's one, I think. It's right there. It's a little brass fitting, and it's two different metals coming together that then rot out and cause a leak. And they're used by, what is it the Veeder LLD tester thing? Yeah, one. But the guy, this one that I caught, that guy wasn't even certified as a contractor. So it's like, dude.
Our bigger issue with them is they can break off if a crash valve breaks and fuel is coming out below the poppet valve.
Yeah. Yeah, we've seen them, and we tell people get rid of those things. So if you see any sort of, these snap taps, or, they're usually squared up and they're plugged into the STP. It's a dissimilar metal. Tell them to get it out.
Also, it's not installed in accordance with the manufacturer's recommendations.
Also, not installed in accordance with the manufacturer's recommendations, which that's always a good one to hang your hat on. Who else? Oh, up front here. Watch the barriers, Charles. You might fall in the pit there.
Are you still testing your government facilities? And is there a liability with your testing?
No, first thing we do is we ask permission. And we explain to them what we're doing, and we haven't had anybody say no. Sometimes we get, can you come back, at 11 o'clock in the morning when it's not busy? Can you come here or there? We'll work around people. But we haven't had any refusals or issues with it.
Is it just for verification that line is tight, or you said you're not certified?
It's a combination of things, really. Now it's turned into, is their equipment they have there working?
Right. And
did their contractor even do it the right way? And verifying, how did they do it? Because we see these results coming through. So it's really morphed into more than just, let's test this line, see if it leaks. It's turned into much more than that. And now a lot of it is just data being submitted to us turns into a whole investigation, because it's like, that's bull crap.
This is just a quick question for John, as well as whoever the presenter was that said that or the speaker that said that they're pursuing about 7 contracting companies right now. Who made that comment? No? Show a hand.
That was us.
That was, okay.
Mike works together.
Okay, I should have known. Well, are you guys pursuing them through this certification?
Yep.
And that's something that's in the regs?
It's in our regs.
Okay.
Subchapter 13, the whole chapter about...
Is that new regulation, or has been in place for...
We've had it for years. We have just never had the knowledge base, and it's really the effort to put into it. And now we are.
Yeah, we got contractors that we're interested in pursuing, put it like that. But we don't know necessarily the mechanism, because our UST regs don't address the contractors, and these guys are doing shabby work out there, and one in particular we really would want to bring an action against, but we don't know that the regulatory controls that.
We're fortunate that we have that, but again, at a minimum, you could always throw them back to the manufacturer and say, and those guys may even kick them out. If they're fed up with how they're using their equipment, they may say, I'm not recertifying him, he's out.
It's not necessarily the testing equipment, it's more so some of the installers. Like these guys,
Oh, the installers, yeah.
The ball valves, different boxes in the guy's office. We show up, he's like, oh, our balls are in the closet. Like,
All right, that's a personal problem, Omar. We had a question down front.
Perhaps you said it, and if you did, I apologize for not catching that. But you guys all got trained yourselves in advance of this by Petrotite, is that correct?
Correct.
Okay. That sounds great. And how long, how extensive was the training?
It was
just
2
curious what it
days.
involved. How many?
It was 2 days of training from Pecora directly, but then we spent a considerable amount of time out with contractors observing and testing alongside of them to sort of get our feet wet.
That sounds great.
To be able to get up to speed so that we're more confident going out on our own. Yeah, it's an effort, but it's been worth it in our Anyone else have any questions?
Hey, John. First of all, well, as you know, you share your information with us in Pennsylvania, and we followed up.
You never heard that.
No. But we followed up on the same contractor, so if they're not doing it right in New Jersey, they're not doing it right in Pennsylvania also. You know how it is.
Yep.
One thing, I was out with a guy a couple years ago, and it was a master satellite setup, and the mechanical line leak detector never saw the leak. It was where the solenoid valve was. So that's one thing we were looking at strongly in Pennsylvania. The mechanical line leak detector never saw the leak on the satellite dispenser. So something we discovered.
Yeah. So, I mean, really my goal here was, I think you can see, looking at some results, you should all be able to go back home, go to your jobs, wherever you work, whatever you do, and you look at these results with a new eye and be able to ask some questions. And some of them may have very valid explanations, some may not. It's just the idea is you know a little bit more now than hopefully you did when you walked in the door. And that was all I really wanted to accomplish. So thank you for paying attention, and remember, left and right elevator, not the middle. I guess we'll see you upstairs. 5:30? 5:30.
Thanks, man.
And you're free to come up front and play around with equipment if you want.